Welcome back. Well, I don't want to fucking record tiny little sections. Look at this shit. I have to do all of them, and this sucks. But I guess I'll just do two questions at a time because that's faster, I guess. Extraction of lead metal from lead to sulfide has two phases. So, let's look at this. PBS and oxygen gas are strongly heated using these minerals shown below. Lead to oxide and gas X. Underline this. In the combustion tube, gas X is passed into acidified potassium dichromate. Okay, so remember, because it's acidified dichromate, that means that gas X is a reducing agent, because this is an oxidizing agent. Um, so just the method to obtain oxygen from air. This is a memorization question. Are you fucking happy? I am. It's Unit 1 again. You have to write fractional distillation of liquid air. There really is no like trick to this. You just have to memorize this. I'm so sorry. It's always like this. The first A part or like B part are always like memorizing. Also, remember, of liquid air. You have to write of liquid air. If you don't, they will take away all your points. Because of what? Of bananas? Of oranges? I don't like that. What is gas X? Okay, looking back at this again, you can you can kind of deduce what it is. PBS, man. So S gets like removed from the system. I wonder what it gives. But first, let's look at this. Here. Write the chemical equation for the reaction that occurs in the combustion tube. This is why you read ahead, because here you can write the equation first, so that you don't have to think about what gas X is. You can deduce it from here. Here it says it gives lead oxide and gas X. PbO. Remember, because S is group 6, it is 2 minus. So Pb must be 2 plus if you don't remember that. And PbO, that's the thing we're going for, and gas X. I wonder what gas comes from these two gases. Okay, it's SO2. Here's the problem though. We have two O's and there's three O's over here. We have to double the lead oxide to give an actual solution. But how do we do that? Now we have two of these. Oh no, we have two lead sulfides and there's two S's. What do I do? Well, you double this too. So now you get 2SO2, which is 4 O's and 2 O's here. So 6 O's. Divide by 2, you get 3 oxygen molecules. So whoopie-doo, we got the gas X here. So gas X is SO2. Write an ionic equation for the reaction between gas X and acidified. This is redox. I'm surprised they're asking redox so early, but you know, you can't really predict this. It's really hard for a person to just simply turn half equations into a full one, so you have to look very closely. Remember what this gives after it gets reduced. It gives 2Cr3+. Cr3+ is the ionic form of chromium, and there's two chromiums here, so it gives off two chromium ions. 7 O's here. Wait, no, hold on. Wait, don't do the O's first. Look at the charge. 7 O's, oxidation number -2, 14. -2 plus 14, 12. Divide by 2, 6. That means there's a total of plus 12 charge here because there's two CRs. There's two CRs here of 3 plus, so it's positive 6. So because it's positive 12 to 6, we have to add 6 electrons. 7 O's here, so we have 7H2O. 7H2O. 7 times 2 H's, 14H plus. That's the step you want to do every time you want to balance a acidic half equation. Because if you're doing alkaline, you have to put in OH minus instead of H plus. And also, please remember this, this, what the fuck, flowchart. You have to first find the oxidation number so you can add the electrons and then count the O's. Add O's where they aren't, as in if it's on the left, you add it to the right. And then you count the H's and you put H pluses on the side that doesn't have the H's. And let's do gas X. which is SO2. It gives, okay, okay, hear me out. So every time you do a sulfur compound, it always gets reduced to, oh, and oxidized to sulfates, a sulfate ion, or a sulfites into a sulfur dioxide. This is like reversible, kind of, okay? Yeah, just count the fucking oxidation number again, okay? Minus 2 times 4, minus 8, so negative 2 plus 8, 6. This is plus 6. Negative 2 times 2, negative 4 plus 4. So the electrons go on this side this time. Now continuing, 2 4s versus 2 O's. So 2 O's go here in the form of H2O. And there's 2 H2s, so there's 4 H pluses. Just like that. And now you have to compare electrons. There's 2 here, 6 here. So there's 3 times the amount of both product and reactants here. So there's 3 SO2s, 6 H2Os, 3 of these, 12 of these. And then you compare the rest of the variables. 6 H2Os, 7 H2Os, that means there's 1 H2O on the product side. 12 H pluses, 14 H pluses, 2 H pluses on the reactant side. So let's look at the answer. Yeah, you just combine all of them together. See, 1 H2O, 2 H pluses. There you go, there you go, there you fucking go. And this one's right too, if I'm looking correct. Yep, 2 3 2 2. 2 3 2 2. Alright, D. In view of laboratory safety, explain whether the experiment should be performed. Explain your answer, explain your answer. Okay, so firstly, where? This is obvious, fume cupboard. It's always fume cupboard. Because, hold on. Okay, you can't really fucking see it. The gas is SO2. SO2 is toxic. That's the answer. SO2 is toxic. Where is it? Yep. I mean, okay, I was kind of wrong. Lead compounds are toxic, not SO2. SO2 is an irritant on the human respiratory system. Here. Whoopsies, I got that one a little bit wrong. Let me just write that down real quick. Okay, I wrote it down in my notebook. Okay, last part of 2. Taking a little bit longer than I expected. Stage 2. The lead 2 oxide formed in the combustion tube is separated and placed on a charcoal block. Charcoal block. Charcoal block. The oxide is then strongly heated as shown below. So if you remember the ECS table, which is top 3, top 10, bottom 3. So there should be 3 metals that you can just heat the oxide directly, which is silver, gold, mercury, those 3. And then the top 5, magnesium, aluminium, sodium, potassium.
YouTube music is just like most music apps.
Oh, fuck off, ad.
Like most music apps. For example,
wait, is it just 4?
toggle thingy.
I am the worst ever, okay? Okay, don't listen to me. Just remember the ECS table, pull it out from your chem test books. Just do it, just fucking do it. Oh my god. Tin is SB, okay. Bueno, SN. I mean, I don't remember all of them, but like, just remember it's these-ish. These are the important ones. And here, oh, lead 2 oxide heated with a charcoal block. So that means it's in the middle reactivity. Like, all the metals in the middle require carbon reduction. Alright, and carbon. So now let's see here. Describe the appearance of the solid product formed from stage 2. Lead 2 oxide turns into lead, so you have to name a silvery metallic solid. Okay, name the appearance and state. Okay, silvery solid would be fine, but add metallic as well because lead is a metal. Let's see, gray, silvery, shiny, metallic solid. Yep, there we go. In terms of oxidation number, explain whether the reaction in stage 2 is a redox reaction. If you don't want to count in your head, write it down. PbO plus CO2 plus to Pb. Count oxidation numbers, okay? C has 0, Pb has 0, because they're both elements. And now we're looking at this. O, -4 plus 4. So -2 plus 2. Alright. Oh, I don't know, man. Is it a redox reaction? Yes, it is. So you need to only name one side to see which one's the oxidizing agent, reducing agent, whatever. Just say Pb's ON reduced from +2 to 0. There, okay? That's the answer. Oh yeah, I've not saved it right. Yes. Okay. Alright, question 2 done. I hope you could do that one. Question 3. I love this question. No, I don't. According to the above experimental results, arrange these three metals in descending order. Look at the table. Let's see here. Reaction with water, A, B, C. C reacts vigorously. It's potassium, sodium, aluminium, lithium, etc. So let's look at the rest of this. Oh, burns with lilac flame. Burns with lilac flame, K. That's the answer. So C is a K, or potassium. And let's look at the rest. Dilute hydrochloric acid, colorless gas Y evolves moderately, no observable change. B is silver. Or, well, I mean, silver is the most common metal they ask in the bottom reactivity list. So just assume it's silver, gold, whatever. And Fe, Cu, well, no, not Cu. Cu doesn't react with acid. That's a memorization thing again. Lead. I don't know any of these. Oh, no. White solids obtained after cooling. That's lead. My bad. Okay. According to the above experimental results, range these three metals. C is the most reactive. Descending order. So next one should be less reactive. A. And least reactive. B. This is memorization again, technically, but not really, because you can just look at this. Suggested test with gas Y. Metals are a base, and if you put them with acid, they give us salt and water. Well, not water. It gives hydrogen gas, and that's what gas Y is. It's hydrogen gas. Burning splint. That's the answer. Burning splint. Pop sound. If Y is in or not detected. Oops. There you go. State an unexpected observation when metal C reacts vigorously with water. Okay, metal C is K. Memorize the freaking reaction. Look, I don't really have any witty things to say here. You just have to remember that all of the alkaline earth metal, not all of them, I hate umbrella terms. Most alkaline earth metals and alkali metals react with water to give a hydroxide. Okay, and just do balancing in your whatever preferred way to get yourself this sort of equation. And now if you look at this, two things happen. The solid potassium dissolves into an aqueous solution and gas is formed. So you can answer either of those. Shiny metallic object solid dissolves into solution, or colorless bubbles are given. Where is it? Yeah, metal C dissolves, metal C drags, sparks are observed, lilac flame observed. This is from the exothermic nature of this reaction. But here you see white fume evolves, or colorless gas evolves. Yeah. And explain why it is dangerous to carry out the reaction of metal C with dilute hydrochloric acid. Let's think here. Really strong alkali metal reacts with HCl. I wonder what's gonna happen if I put these two together. Huh. Strange. I mean, there's a reason why you don't see potassium chloride a lot. That's because it's too exothermic. That's a keyword. Too exothermic. Or slash, you can answer this as well. Explosive. You can say the reaction is explosive. That's why it's too dangerous. Let's see. Highly exothermic, explosive, may splash out and burn the skin. I think this part is important too, because considering you're working with acid, and that's why it's better to do this reaction with water, even though it gives off KOH. You know, just a thing, just a heads up. Okay, last part of 3D. Let's get through this. Okay, using the following items only, outline the experimental procedure and state an expected observation to confirm the relative reactivities of metal A and B. Look at it very closely. Strip of metal A, strip of metal B, A nitrate, B nitrate. That makes sense, and also test tubes. Remember that. So, if I were to write it, I want to use. Yo, are you serious? Someone's calling me.